Welcome to the Penn Engineering at the University of Pennsylvania. This is our PhD open house. The two programs we're going to be covering today are Computer and Information Science and Electrical Systems Engineering. So just some housekeeping information. So we are being recorded, so you don't need to worry about missing any information or taking notes. You'll be able to find this webinar on our YouTube channel probably within the next few weeks. And you can also check out any of our past recordings as well. If you have questions, please submit your questions to the Q&A section in the Zoom toolbar. We have some of our great colleagues here who will be able to answer questions behind the scenes. And we also will have some questions answered live depending on the program being covered. So just an overview of what we'll be covering today, some introductions. We're going to go over the University of Pennsylvania PhD programs overview, admissions, the Computer Information Science program, and then Electrical Systems Engineering program. So I'll go ahead and introduce myself first. I'm Jacqueline Aldworth. I'm the PhD admissions manager. We also have Abby Cockstein, who's the Associate Director of Graduate Admissions. And then I'm also going to hand it over to Dr. Liu, who's the Senior Associate Dean of Global and Education and Global Initiatives.
All right, thank you. It's great to see everyone here today, exploring our PhD programs in Computer and Information Science and also Electrical and Systems Engineering. My name is Buntao Lu. I'm the Senior Associate Dean. I oversee all our PhD and Master's programs. I'm also a faculty member in both CIS and ESE. And the first thing I would say is this is really a great time to join Penn Engineering. We have a lot of exciting work, exciting centers that are being created. And also, you'll be coming into several new buildings that's coming up in the engineering school. We have the Vagelos Laboratory for Energy Science and Technology, which will focus on sustainable energy solutions, very relevant to CIS and ESE. The Amy Gutman Hall is going to be a state-of-the-art facility for data science and computation. Many of our faculty in computer science are moving to that building. And that's really going to put us at the forefront of AI and robotics and all types of digital advancements. And also, if you walk a little bit further, there's the UCD, which really is a hub that bridges engineering and medicine. So we could address health challenges in what we call the precision engineering for health. And next to it, we have Venture Lab, which is at Tangen Hall for entrepreneurship. That's something we care a lot about. And maybe some of you at some point, if you come to Penn, be interested in creating companies doing technology transfer. So there's going to be a lot of research centers, and you're going to hear some of them today. For example, Graphs for Robotics, the ASET Center for Trustworthy AI, and Ideas, which is on using AI to solve engineering challenges. We are very interdisciplinary. So I'm part of the Distributed Systems Lab, or DSL, which is directed by Professor Vincent Liu. And many of us work in close proximity in the areas of distributed systems, ranging from traditional systems work, high performance data processing, formal methods, cybersecurity, hardware, software interface, and more. So anytime you come to our lab, you really see faculty, students working across many different areas and interacting together. And I think this is a common theme you will hear from our representatives from CIS and ESE. And again, thank you so much for joining the call. I'm going to hand it off to my CIS colleagues, followed by ESE. There'll be faculty members, PhD coordinators, and also students who can tell you all about their exciting work. And very much look forward to seeing your application.
Thank you so much. So we're going to move on now to go over the University of Pennsylvania. Just some information if you're not aware of it. So we are the first university in the nation. It was founded in 1740 by Benjamin Franklin. Penn Engineering was founded in 1852. So we're a large school with over 26,000 students, and the majority of those students being graduate students. Almost 300 acres of land across the city of Philadelphia. We have 12 graduate schools across the university. 15 master's programs, so 6 PhD programs within the School of Engineering. We have 19 research centers and institutes. We have access to incredible resources such as libraries, centers for affinity groups, multiple fitness centers, career services support, just to name a few. And we're located in the exciting and innovative city of Philadelphia. So a little bit more about Philadelphia. If you may not know, we are known as the city of brotherly love. We are the 6th largest city in the nation. The picture you're seeing here is a view from the Schuylkill River in Philadelphia. We are known as the birthplace of the nation. As you know, we have the first university. So we're an incredibly old city compared to American standards, but it's filled with innovation, and we are home to a lot of firsts, first planned city, the first zoo, the first public library, and the first hospital. We have rich history, art, culture, educational opportunities. We're a very affordable city compared to most big cities in the country. And we are located just 2 hours from NYC and Washington, D.C., and it's very easily to commute to other cities. We have accessible public transportation, beautiful parks and outdoor spaces. We do have many students that live on campus, but there are a lot of amazing neighborhoods to check out. We have the largest urban park in the world, known as Fairmount Park, where you can row, bike, hike, walk, and explore. And Philadelphia has turned into a hub for life sciences, tech manufacturing, and science center. So it's a great opportunity for jobs within the tech industry. So we do have 6 PhD programs, as I mentioned: bioengineering, chemical and biomolecular engineering, computer and information science, electrical and systems engineering, material science and engineering, and then mechanical engineering and applied mechanics. But the 2 we're going to be covering today are computer and information science and electrical and systems engineering. So the application requirements, I know a lot of you are familiar with these, but I'm going to go over them real quick. So required, we do have an online application. We do need a resume, a personal statement, letters of recommendation. So we typically say it's good to have at least 1 academic and 1 professional. Begin having conversations with your potential recommenders early. We require, like I said, 1 letter to be academic in nature and 1 to be professional. If you've been out of school for a number of years, you can substitute academic for a professional one. Make sure that your recommender agrees to write you a positive letter of recommendation. We can't stress this enough. And then we do not require your letters of recommendation to be on professional letterhead, but when possible, it is a best practice. Our application fee, unfortunately, we do not waive the $90 application fee for any reason, and this fee must be submitted in order to have your application reviewed for admission. Your transcripts, you must submit unofficial transcripts from each university or college you attended. Even if you went somewhere and took 2 courses, we still need to see those transcripts. They must be in English, and your transcripts must include courses taken, credit hours, and grades earned. In terms of the English proficiency score, this is only applicable for non-US citizens and those whose first language is not English. And we will go into detail in that in the next slide a little bit more. And then GRE scores are optional. If you choose to submit your GRE scores, they must be official and must be sent directly from ETS. They need to be from the past 5 years to be valid. And the GRE is a great option if you've been out of school for a long time and want to show your quantitative ability or to supplement any lower grades. So the English proficiency scores and waivers, applicants that are non-citizens and citizens whose first language is not English must submit English proficiency scores. So TOEFL, we're looking at like 100 plus. IELTS is a 7.5 plus, and the Duolingo is 135 plus. So waivers are processed manually after you applied. A waiver, so you can get a waiver if you meet any of the following criteria or will graduate from a program in the US. So if you're currently in a master's program somewhere else in the US, that's how you will get your waiver. Once you graduate, we'll be able to give you that waiver. And from a school in a country with an English as an official language, or from a school where the medium of instruction is English, and is clearly indicated on the transcript. The deadline for the PhD application is December 16th, and all decisions are released by early April. Again, the deadline is December 16th, coming up soon, and then all decisions are released by early April. And if you have any more questions, feel free to take a snapshot of one of these codes. So we have an FAQ database, requests for more information, that will get you in contact with us. And we do have additional events coming up this fall. So we have 2 more PhD open houses for our other programs. We're doing a series of 3. We do have a coffee chat, and then we do have some also Ask Admissions events as well. So you can get more information on those by scanning the QR code. And with that, I will hand it over to our first program.
Okay, I will let Professor Anindya Day kick it off. He is our graduate group chair, and he's going to start off by talking a little bit about the admissions process.
So hi, everyone. My name is Anindya Day. I'm the graduate chair for Computer and Information Science. So that means I oversee the program, the PhD program in computer science. So I'm just going to briefly go over the application process. So after I finish, Britton will tell you more about the programs. So she knows everything I know plus more. So she will tell you a little more. And then you'll also get to meet some of our students who are currently in the PhD program. So they can give you more details about the specific labs, etc., and also student vantage point of things. Okay. So it's hard to overemphasize this. This is a great time to do computer science. It's become part of the common conversation now. And at Penn, essentially every research area is covered, ranging from the very foundational parts of algorithms all the way to databases, system design, AI, programming languages, as well as interdisciplinary collaborations with things like biology, electrical engineering, linguistics, language, math, genetics, you name it. And we are, of course, like, we do great research here, so there's impact in the research world, but this also translates all the way to the real world. In particular, the work that is done here has real impact on startups and products in the world. Many of our faculty are also involved in various kinds of startups and companies. So this is Penn. If you're looking to do a PhD in computer science, Penn is a great place to do it. As far as the application goes, of course, because you're applying to a PhD program, we expect an undergraduate degree in engineering discipline or natural sciences like math, physics, or something, or statistics, something quantitative, as a major with a strong quantitative component. Of course, traditionally, most of our students probably have a computer science or computer engineering background. So if you're in doubt about whether or not your undergraduate background is right for applying to our PhD program, definitely reach out to us, reach out to Britton, reach out to me, and we can answer that for you. As far as the application goes, I cannot emphasize this enough. Probably the first thing is your recommendation letters matter a lot. So I would definitely say if you have a choice between a professional letter and an academic letter, go for the academic letter, because we want to see how good a fit are you for our research program. Of course, sometimes if you're out of school or you do not think you are not able to arrange good recommendation letters from academia, then maybe go for professional ones, but always lean on the side of academic letters. Other than that, transcripts, GRE is optional. I don't, again, like I and most of my colleagues probably don't look at the GRE score really, so GRE is really optional. Everything about the English proficiency test that was already discussed. Send your transcripts. And in the personal statement, maybe one thing to note here is that we are trying to assess your fit for the PhD program. So maybe the best thing to do in the personal statement is make a case for why you think you are going to be successful in the PhD program. So this could involve instantiations of what kind of projects you have done in your undergrad, maybe even in a professional life, if you have been out of school for a while, any advanced courses you have taken. Basically, try to make the case for why you're a good fit for the PhD program. So, and highlight those things, because again, like, we received thousands of applications, so highlighting those things is really important. Concentration areas, as I said, we essentially have our research spans essentially every area of computer science. One thing to mention here is that if you are applying for machine learning plus X as a concentration, then only some of the other options could be used as concentration, the second and third option, and those have been highlighted. But other than that, we essentially span every research area of computer science. And just some statistics. So about 1,500 students apply to our doctoral program. The acceptance rate is about 6-7%, something like that. Like 92 students were admitted last year, of which 37 chose to come here. And as you expect, the largest fraction of our students come from the United States. But China is a second one, and then students come from India and all over the world, really. And the application deadline is December 16th, and you will get your notification. The decisions are made on a weekly basis, really. So you might get a notification, you might hear of your result or the outcome before that, but the notification deadline is April 1st. And as usual, everywhere, April 15th is the deadline across universities for you to give, if you have been admitted, to give your decision whether or not you want to join Penn. We very much hope that if you apply and are admitted to Penn, you choose to come to Penn.
Thanks, Anindya. I'm going to switch into program structure and then end with a bit of the resources and support that we have, and then also speak with our current students who are on the call. So the first things to go over, there are 6 guiding principles that we base the program around and that will guide you along your journey. Excuse me. The first of that is your breadth across multiple graduate level subfields of computer science. This will come through your coursework. Then also your mastery in depth of a specific research area that you begin working on once you start. Engagement with research during your first 2 years of the program. I will go into how you're going to accomplish that further along. And then your written and oral communication skills are also a big pillar that we want to shape and mold as you're on this journey. Practice in teaching, and then a significant contribution to knowledge by the end of the program, which is the result of it's the dissertation. So just a brief overview to kind of hammer down these pillars and make it that you guys are receiving what you need in the program, but also reaching that dissertation at the end. We start with the coursework. So that's going to be the breadth courses. That's 2 credit units, and you are able to choose them from 5 research buckets. This is something that can be waived if you come in to the program with a master's in computer science. Then we move into the depth courses, and this is going to be 4 graduate level electives that do somehow relate to the research that you were doing. And you'll get more clear of that along the way. Another course is going to be, this is a university required course. It's the responsible conduct for research. And that's going to kind of go into the ethics around conducting your research as you move into publications and are more on that path towards the thesis and dissertation. And then the last 2, independent studies, you're going to be doing them throughout your time in the program. Typically, you're going to do this with your advisor. Some students have more than one advisor. You also can opt to do this with a potential faculty member that you might be publishing with, may also be within your lab. So it's a nice opportunity to possibly work with someone else for a semester and work towards something that contributes to your research. And then last, you will have thesis and dissertation studies along the way. There's just 2 CUs required, but these are all very easy to meet because you are full-time the whole way. So once you're done with the coursework, you tend to start enrolling in those independent studies and the thesis dissertation. The milestones along the way. So to kind of emphasize the pillar of the research excellence again, you are going to be expected to do a research qualifier within the first 2 years. This has a written report and then an oral presentation. The report is around 5,000 to 10,000 words, and then the presentation is expected to be 45 minutes. This is a great practice for your thesis proposal. You also are expected to do 2 semesters of teaching, so TAing a course of interest to you, a course that relates to your research, a course that maybe you did really well with in your undergrad or master's program. And then from the 3rd year onward, you really want to start working on the thesis proposal and preparing for the big to-do of all, the dissertation. So just briefly, here are the 5 buckets for that breadth course, the course requirements that I mentioned. There are 5 buckets. The Mathematical Foundations has 12 courses. System Design and Implementation has 20 courses. And then Learning and Modeling has 13 options. Human-Centered Computing has 10. And then lastly, the Technical Communication. You can choose to do a writing and speaking style. So a wide variety of courses. This doesn't even list all of the depth that you could do. You can also do depth outside of the CIS umbrella. You could take courses in ESE, in the mechanical department. So we really, we want you to mold your credit units and mold your degree the way you see fit and the way it relates to your research. And then just lastly, just to give you an idea of how everything kind of equals those 14 credit units. This is kind of the stuff I was mentioning before with the independent studies and the research. We currently have 51 tenured and research faculty. We have around 220 PhD students, and we have a strong collaborative community across campus. We cover a wide array of research areas across computer and information science. We broke those down to just reflect these 4 specifically. So the intelligent systems, AI, data science, the human-centered computing, computer systems, foundations of computing. I can provide to you guys a link afterwards that has a nice breakdown of all of these and shows you exactly which faculty in each area crossover and who's working amongst these groups. I won't read all of this for the sake of time, but just to break down each of those 4 that I mentioned, these are the areas that fall under each research area that I mentioned. So when you are selecting the concentrations, just think about these areas, think about, what you might want to work on. You do have up to, I believe it's up to 3 choices to select. So definitely pick the ones that you feel align the most with what you want to do. Just to wrap that up, human-centered computing, they have a smaller subgroup, but they do have 2 different areas and different centers that you can be involved in if you do choose that area. Computer systems, it's not quite as much as the intelligent systems, but they have a large group and a lot of different areas you can branch out into. And then lastly, the foundations of computation. So this is the fun stuff, social extracurriculars. We have a great group of students. All of them have found a way to be involved one way or another. Some people are on the forefront of our mentorship program. We currently have over 90 students involved. They do monthly weekend outings, even some stuff in the evenings. It's a really great chance for you to be paired with a senior class member senior cohort member, senior PhD member that aligns with you on research. You also can be paired with someone that maybe has the same advisor as you, or that you just align with on a personal level. That's the nice thing about the mentorship program. We do try to match people with who they fit the best with. And it's a great opportunity to do stuff outside of the Penn bubble and the CIS bubble. Sometimes it really gives you a chance to build relationships that aren't just related to the research and, your progress in the program. There's also weekly TGIFs every Friday. This is for PhDs, faculty, and postdocs. And then along the way, there also will be opportunities for leadership roles if that's something that you're interested in. I've just listed a few below there. And then, as Anindya said, the future is very bright. We have great faculty and students. that are growing and want to work with you. As I believe Boone did mention, there is the new Amy Gutman Hall. Several faculty and students within the CIS PhD program will be moving to the new data science building, Amy Gutman Hall. It's going to serve as a cross-disciplinary hub for collaborations with 12 other schools. So it will be a really exciting place that all are welcome to go to, even if you aren't ended up being located there permanently. It's been in the works for a while, so we're really excited about it. I've included some pictures that are not even the most up to date, but that will be a very exciting building, and hopefully it will be where the open house is, which I will get into in the resources and support. Every student that gets admitted gets invited to our admitted student visit weekend. This year it will be Friday, March 21st through the Saturday. This is a great opportunity for you to come if you are an admitted student and meet all of our faculty, our current PhD students. Everyone really makes an effort to be a part of this day, and it really gives you an idea of the campus. We have faculty talks. You will be accommodated for 2 nights. There's meals, there's more. For the sense of time, I'm not going to go into all of the details, but it's a really great chance for you to kind of see what's possible and get a taste of CIS. It's one of the highlights of our spring semester. So I really, I hope for those of you that do get admitted, it's something that you can join us for. These are just a few pictures of our last year one with our students collaborating in that first picture. We had a faculty panel, which was great. And then the student panel, which is always everybody's favorite part. So just to kind of close out for the support piece, the grad admissions team, they're awesome. You're going to want to contact them for any support or guidance navigating your actual application, the system requirements. So if you're having issues uploading, if you're not sure about when, if your letter can be uploaded using the app portfolio that they use, anything like that, you want to ask them. They are the go-to. So it's who you had met before. Jacqueline Aldworth is a PhD admissions manager, and then Abby Kalstein is the associate director of grad admissions. Abby did not join us today, but Abby Whittington is one of the admissions specialists who also is just a great source of knowledge for anything application related if you're having issues. And then in terms of the contacts for the program, again, it's me. If you have any questions about the research areas, the concentrations, anything that's more program related in the application system, you can contact me. If it's anything about the program or anything about what your time might look like, then I've included who our student speakers will be today. I included their emails. And then, of course, Professor and India Day, who's our grad group, definitely contact them if you have more specific questions that I might not be able to answer if it's out of the realm of just your application. Okay, to the fun stuff. I'm going to stop sharing. We have 3 students joining us today. I'm going to jump into introducing them. We have Hitha, Jason, and Spiros joining. So I'm just going to allow some time for each of them to just briefly introduce themselves and then give you their background. Maybe you guys could mention just your undergrad institution, your year in the program, and the current research area that you're working in. And then I'll shift into a few one-off questions. So I'll start, Spiros, you're first on my screen. So I'll just start with you. What's your background, research area, year in the program?
Hi everyone, thanks Britton. So I'm Spiros, I'm a 3rd year PhD student, working with Professor Vincent Liu. My research focus is using techniques from programming languages and compilers to speed up distributed applications. And yeah, my background is I'm actually an international student from Greece. So I did my bachelor's and master's at National Technical University of Athens. So yeah, that's me. If you have any questions, everyone, please feel free to ask. So yeah, Brayton, you are muted. Brayton, you are muted.
Thank you. Thanks for catching that. Hita, if you want to go next and just kind of give a quick brief overview of your background research area.
Yeah, sounds good. So I'm Hita. I'm also a third year PhD student. I'm co-advised by Andrew Head and Kevin Johnson. And my work is in the intersection of human AI interaction and medical NLP. I did my undergrad at Carnegie Mellon in Pittsburgh. And yeah, that's me. Happy to answer any questions about student life, choosing a research area, transitioning into the PhD straight from undergrad, anything like that.
Jason, if you want to go ahead.
Yeah. Hi, everyone. I'm Jason. I'm a second year PhD student in the GRASP lab, advised by CJ Taylor. My research is in planning and localization. And then my undergrad was Fordham University in New York, and I also did my master's there. And then I worked for 2 years for Army Research Labs before coming to Penn.
Great. And then I'll keep it on you, Jason, and then I'll after you answer, I'll have Spiros and Hita answer this question. Could you just briefly tell, the students joining, like what made you specifically decide that the PhD was the next option for you, and maybe why you didn't want to stay in either academia or industry after your undergrad and master's?
Yeah. I think for me, it was a lot of the work that I had been doing. I was working with a lot of PhD students or people who had PhDs already. And I just enjoyed the challenging problems that they were working on and helping them. And I wanted to make some of those projects my own. So that's kind of what drove me to think about doing a PhD and ultimately applying and doing it.
Spiros, if you want to answer the same question.
Yeah, of course. So the decision to apply for PhDs came to me around midway through my bachelor's because I really enjoyed computer science and all the topics related with it. But I couldn't imagine myself going directly to industry, especially during my early and mid-20s, because I felt like I wanted to do something creative, and research is, in my mind, the epitome of creativity. So yeah, it came natural to me.
Great. And then the just same question for you.
Yeah, so I, similar to Spiros, decided like late into undergrad that I wanted to pursue a PhD. I mostly saw like the space of research or like the problem opportunity space that I was interested in as something that I could contribute to either as like someone in a biotech startup or as a researcher. And I think the more I learned about medical informatics and human AI interaction, I just felt like it made more sense for me to contribute as a researcher, and a PhD was like a natural choice thereafter.
Great. And then if you guys like do remember, I know that being in the second and third year, it might be a little bit blurry, but is there anything that you specifically remember doing or how you prepared beforehand that you do think made a difference, or just in general, like tips on the application process in general? So Spiros, again, you popped up on my screen first, so if you want to answer that one.
Yeah, of course. So when I was applying for PhDs, the main thing that I was doing was looking at the for each university, I was looking at the labs, and for the lab that I was interested in, I would go through the papers from each of the professors and see if any of those is close to my research interests or the topics that I would like to pursue through my PhD. So I skimmed through most of the papers, and when I was writing the statement of purpose, I would specialize it to match specific professor's interest. So I think this is yeah, this is the thing that I was doing.
Great. Thanks. And then Jason, and then if you want to go after him, just the same question, any special tips or how you prepared to apply?
Yeah, similar to Spiros, I also looked at the labs at the schools I was applying to, talked to my advisors, see who they knew, see who they had good opinions of, and then look at the labs, read their papers, see what interests you, and then really think about how I could build off of what they were doing, and in a way that would interest me, and also be good for the lab moving forward, and then kind of give myself ideas to talk about in my statement.
Yeah, so I think that I narrowed down the search by choosing universities that like where I could see myself working with at least 3 faculty. So that was helpful for me to figure out where I wanted to apply. And then preparing the application, I think like around this time, my application cycle, I reached out to faculty that I was interested in working with, and just started conversations with them on like what their current research interests were. Oftentimes websites aren't wildly up to date, so having a conversation with faculty and figuring out where they see their like research agenda being 3 to 5 years from now when you're in the crux of your PhD is super useful. Yeah.
Thanks, Hitha. That is a great point. We do encourage people, if you have, your 4 faculty in mind that you are selecting in the application, always reach out. It's not a guarantee that everyone will get back to you, just due to the nature of, their work and how busy they can be, but we do encourage it. And, faculty do know this is the application season, and sometimes that's, that leads to a conversation that leads to you speaking with them more and kind of leads to them going to your application first when they go to review everything. The people you do select in the application system will automatically be reviewing your application, but there's no harm in reaching out ahead of time if there's someone you really like are looking forward to working with. And then, so I just have a couple more questions. Maybe we'll just do like 1 or 2 more to wrap up. I'm curious if there were any courses that you guys have found most useful with aligning to your research, or just that you enjoyed that maybe put you on a different path of research that you hadn't thought of, because as we saw, the course list is pretty extensive. So if you have any insights on maybe courses you took that you aligned with well or would suggest. So whoever wants to go first for that one.
Yeah. For me, one of the great courses that I took in the first 2 years was Software Foundations. And it's a great course for everyone who wants to pursue research in topics related to programming languages. And actually here at Penn, we have a great group of people doing programming languages, so you will get the best out of it. So if you are aiming to do research close to that area, do take this course, please.
For me, all the 2 vision courses, so computer vision and then advanced topics in computer vision have been super helpful. I mostly come from a optimization and controls background, so now that I'm doing more like planning research, those have been helpful. Also, advanced topics in deep learning, where we talk about all the big models that everyone's talking about, GPT and the diffusion models and all that stuff. Super relevant for everything that's happening in the world, and really a great class.
I found that the department's like advanced seminars, like CIS 7000 courses, are really useful. You kind of get to interact with professors in the domain that they're most excited about teaching because they choose the course content. So like right now I'm in a conversational agents class, and it's just a good way of kind of brushing up your knowledge of the literature in that domain, and also working towards a final project that may or may not result in like a workshop paper or something like that.
Great. Thanks. I want to give some time if anyone has questions specifically for students that are on. Now would just be a good time for that. I will be hopping on again at 10:40 and can answer some of the more like generic application or program questions. But if you do have something right now, if you want to type it into the Q&A box for the students specifically. So you guys could take this question as well. I'll answer it briefly. The question is, what should typically be included in the email we send to faculty ahead of time? Should be a CV, statement of purpose. Of course, I think those materials help. I think it gives them a sense of who you are. It kind of answers a lot of questions they might have. That would be a follow-up email to you anyway. So I do think it's always good to include that when you're reaching out. Do Jason, Spiros, or Hitha, do you guys have any tips or anything that you've included when you are reaching out to a faculty member, even now in the program, that you find useful in including in the email when you're trying to make that connection?
I think a CV is certainly helpful. Like in the email, if you state your broad research interests, then that'll give them a sense of like whether there's some intersection in your interests.
So what I would suggest is to keep the email short. Professors get 1 million of emails per week, so don't even get discouraged if you do not get any answer, because it's highly probable that the professors will miss the email, or they will not have time to actually read it. So please keep it short and to the point. So yeah, as Hita said, a CV is great for them to scan your background, and then you can just mention that you are interested in 1 or 2 of their papers. And that's it. Anything longer than that would just make the professor be like, oof, I don't want to read this. So yeah.
Yeah, I was gonna say the same thing. Keeping it short and to the point is good.
Great. Thanks, guys. Another question. So this would be good if you guys have worked with other faculty that are maybe outside of your assigned advisors or different research areas. What do opportunities to do interdisciplinary work look like as a PhD student? So if you are interested in kind of tapping into those other areas that fall into our like foundational research areas, how have you gone about it, and what has it been like for you?
So I think it's been a relatively smooth process for me. So one of my advisors has a joint appointment in the med school, and through that we've been able to connect with surgeons who have interesting data for us to use. And in general, I think people are willing to work both intra-department and inter-department collaboration. So yeah, no complaints there. It just starts off with an email or, meeting someone at a conference. There are a lot of like Penn-wide conferences as well. So you can connect with many people here. So it's pretty straightforward.
I think there's also like a lot of interdisciplinary projects that professors get funded for already. So the two projects that I work on, I actually work with no other students that my advisor advises. So one of the projects is also with the med school, so we meet with them every week, and then the other project is everyone is in the grass lab that works on it, but I'm the only one from my advisors group, so everyone I work with is from other groups. So yeah, it's very easy to I think mingle and meet students from other advisors and start projects with them. And a lot of time it's already happening through funding and co-funding.
Yeah, me personally, I don't have much experience with working with more than one professor at a time, but I think doing independent studies early in your PhD program is great because you can work with different people. And if you find like an intersection between the work that you are doing with those people, there is a high probability that you could translate this into a collaboration between them. So feel free to reach out to different people during your early stages of your PhD and see what happens.
Thanks, guys. I think we'll do just one more specifically for students. How frequently would you say that you guys are publishing papers once you move into the research after the coursework and you're more focused on the thesis and research areas?
There are two main waves of conferences, like one in the beginning of the year, one in the middle of the year that we target. How many of those submissions get accepted is like another conversation, but I guess generally I guess for our field, we publish like twice a year. That definitely very much varies based on your research area though.
So yeah, it really varies with the research area. Like I'm on the systems sides of the computer science, and some projects require much more time to implement. So it varies. Like you can submit a paper in 6 months, or you can submit a paper in 2 years. So there is no correct answer to this. It's much more to doing progress throughout the PhD, and when the project is done, you're gonna publish. My experience is that as long as you're doing progress, the papers will come. So don't think about I need to publish once or twice a year. This is not the right mindset for a PhD. It has much more to do with the actual results rather than just submitting papers.
I can also jump in. I think one thing to keep in mind is that it's never like a linear process. You're probably the first 2 years, you're going to struggle more and like deal with the courses. And then after that, it's like an exponential curve. But this doesn't mean that always you're publishing more papers. It could be like either the quality of the papers you're publishing is getting better, or the number of the paper you're publishing is getting more. It really depends on the goals that you set and you try to achieve, but just knowing that it's not like a linear process where you can measure 2 papers per year or 3 papers per year. It's usually like an exponential curve for people.
I'm just gonna hop in. I believe at 10 we're crossing over. So this is gonna complete the CIS portion of the presentation. I think we have some ESE students who have also hopped on, so that's going to be great. You can talk to them. I want to thank Spiros and Jason that had to hop off. I will hop on again after ESE has done their presentation and answer a little bit more of the questions around. I saw some around the recommendations and things of that nature, but I want to make sure Nicole and the ESE team gets their time as well. So I will hop back on afterwards. And again, thank you, Jason and Spiros, for joining for the CIS student portion.
Welcome to the Electrical and Systems Engineering Open House. Today we will go through the different research thrusts that we feature in the Electrical and Systems Engineering program at Penn. Talk a little bit about the degree milestones for the PhD degree, where some of our past PhD alumni have gone in their careers, and wrap up by answering any questions you might have. And then we have several of our ESE PhD students who have joined us, who are going to participate in a student panel discussion. And I encourage you to ask lots of questions of them when we come to that part of the presentation. So I'm Troy Olson. I am the graduate group chair for Electrical and Systems Engineering. I am joined by Nicole Contasta, who is our ESE PhD program coordinator. And in the ESE PhD program, we have 3 focus areas that any applicants can choose to apply to. You can also choose to apply to multiple concentrations. Many of our faculty work across these different concentrations. So the first is circuits and computer engineering. And here's a list of the faculty that are primarily centered in that area, although I want to emphasize again, many of our faculty span multiple research thrusts. The second one is nano devices and nanosystems. For example, I am primarily located in that research thrust, but I also do a lot of work in circuits and computer engineering. I think, again, that's typical of many of our faculty. And then information and decision systems, where we have a number of faculty in that area. If you're not familiar with these research areas or research thrusts, and what types of research electrical engineers at the PhD level are doing, I think a cyber physical or IoT system kind of shows the breadth of what electrical engineering is all about. And there are other examples, but maybe I'll walk through this one to start. To me, electrical engineering is about how we interface with the physical world and extract information or do actuation or change in our behaviors based on what we discover. So we invent new sensor technologies for measuring information in the physical world, which is primarily analog, and turning that into digital data. We invent new ways of processing and storing information. So those could be things like transistors or new memory devices or new ways of inventing computer architectures that can process data more efficiently. We look at new ways of building communications, whether that be RF communications or optical communications through fiber. How do we move data around? How do we extract information from data and make decisions? So we look at new ways, algorithms, machine learning for understanding the physical world. And how do we respond to the things that we're understanding? So we build new types of actuators, robotics. So ESE, you can imagine that's really broad, and it covers all of these areas, and all of these areas are encompassed in those 3 research thrusts that I discussed earlier. I'll go through a couple of examples of this. The first one I'll talk about is sensors and what we're doing in that area. Our department and our faculty do a lot of research in new materials for sensing, new methods of sensing. For example, this is a device that was invented in my research laboratory. It's basically a device that can turn magnetic fields into electrical signals, and it's used for sensing, for example, muscles on body. So we basically want to make this into a wearable magnetic field sensor. My colleague Lee Bassett works on new methods for sensing magnetic fields using quantum techniques. And Firuz Aflatooni's lab, they look at ways of building interface electronics for reading out different types of biomedical signals, for example. In the processing and storage area, we do a lot of work in this area, from inventing new memory devices to looking at new types of computer architectures. This is an example from Professor Jing Li's lab, where her lab has figured out how to integrate new types of non-volatile memory monolithically with integrated circuits. And then they construct new ways of devising computer architectures that can take advantage of the co-location of memory and processing. My colleague Deep Jarawala works a lot in new memory technologies at the device level. Andre Dahan leads a new center thinking about the architecture of information processing and how that can be used to enhance security. In the communications area, our department is very active in researching in this area as well. That includes new types of radio frequency communications devices. In this case, this is an optical transceiver that was developed in Professor Aflatooni's lab. His lab works a lot in integrated photonics and using integrated photonics to achieve extremely high data rate optical transceivers. For example, for moving data around in a data center, which is one of the most energy intensive and longest time periods that in a modern data center. And his group has done some really revolutionary work in this area using integrated photonics. My colleague Alejandro Ribeiro, his lab oftentimes thinks of ways that sensor networks or networks of transceivers might configure themselves to figure out how to best route data through a network, or best send and receive data. What's the most efficient way to get the widest data rate communications? So that's more in our information and decision systems area. So in communications, we spread everything from new devices to circuits to new ways of using analytics to tell us how to configure our networks. In terms of analytics, we have a number of faculty in our departments working on things like deep neural networks, ways to ensure that neural networks and AI are safe and reliable so they can be applied to things like medicine and self-driving cars where mistakes really can't happen. We also have a huge NSF center, the IoT for Ag Center, led by my colleague Sherry Kagan. And the goal of that center is actually represented entirely across this chain. It's to collect agricultural data, transmit it, and get it to the cloud, and then use data analytics to tell farmers information that they might use about when to apply certain fertilizers or when to apply irrigation to better use the resources that we have in precision agriculture. So there's a huge data analytics portion of that engineering research center that can take in all of this data measured across the field and figure out what we can learn from that, and then how we can respond based on the information that we learn. And finally, many of you may be applying to the GRASP lab. Penn is very well known for its robotics, and ESE is we have many faculty in the GRASP lab and who work in this area. Actually, our work in this area spans incredible scales. So this is a bio-inspired robot from Dan Kodachek's laboratory. My colleague Mark Miskin, for example, works on the world's smallest robots, building little nano robots that are tens to hundreds of microns on a side, that have little tiny computers and actuators and sensors embedded in them, and can swim around in fluids and track things. Incredibly interesting work going on at Penn across this entire area. So in terms of the milestones for our PhD program, we require all of our students to take 10 course units worth of classes. In general, those would one, get you depth in the area that you're researching, some breadth into some other areas. It could be in electrical engineering or other types of science and engineering. And then some things to build mathematical foundations, critical thinking skills. In addition to the 10 course units, all of our students will take 10 research units. I've never seen a student ever come up short on this one. Usually our students take many, many more than 10 research credits, because every semester you're not taking classes, you're doing 3 course units of research. In the first 2 years, many of our students are focused on their qualifying exams. And so at Penn and ESE, our qualifying exam is basically achieving a certain score in one of 4 courses that are centered in our 3 research themes, in nano devices, circuits and computer engineering, or information and decision systems. And doesn't matter which area you're researching, you can take any 2 of these courses. And as long as you get a specific score on either the final exam or in the course as a whole, which is up to the instructor, then you would pass the qualifier. All of our students also complete 2 semesters of teaching practicum. So if you really want to learn a topic, the best way to learn something, in my view, is to teach it. It requires a level of knowledge beyond that which one would acquire just from taking a class. And so it's a way to develop not only superior knowledge in an area, but also to learn how to explain things to other people, which is really critical in any PhD program and for anyone getting a doctorate degree. In your 3rd year, you'll form a dissertation committee. So that will be composed of your research advisor, who's a faculty member, and at least 2 other faculty members. Over 50% of that committee will need to be in our graduate group, but you can also have people who are external to Penn participate in your dissertation committee. In year 4, nominally, you would perform a candidacy exam. That might be year 5 for some students. Generally, that should be about a year before your defense. And in your candidacy exam, you're going to tell your committee what you're going to complete that's going to make that unique research contribution to the field that warrants the PhD degree. So you're going to tell everybody what you're going to do, what research you're going to perform for your dissertation. And finally, the culmination, which is always a really joyous event for both students and advisors, is when you get to the dissertation defense. That usually happens in the 5th or 6th year. And then you're going to get up in front of your committee and your colleagues and many others in the Penn community and others from elsewhere. Many people bring their families. And you're going to present all the research that you've done while you're at Penn that's culminated in your dissertation defense. And then you'll spend maybe 45 minutes or so just with your committee answering some questions. And sometimes you have to do a few edits to your thesis, but usually by the time you get to this point, you know your topic really well, and you've done the research, and then you'll be ready to graduate. So, our students have quite a broad outcome in terms of where they go after they graduate. So there's a lot of different opportunities available to Penn ESE PhDs. Many of our students end up going into industry and doing research at companies, both large and small. And here's a list of some of the larger companies that our recent graduates have gone on to. Some start their own companies, in fact. Many go on to pursue additional academic pursuits, whether as tenure track faculty or as postdocs. And then several have also gone on to national laboratories. Again, maybe a an intermediate step between academic research and industrial research. And here you can see a list of some of the very prestigious academic institutions that our previous students have joined upon graduating from Penn. In terms of industrial research, about 30% of our students go on to startups, and about 70% either in national labs or in the R&D labs of some of the larger companies that many of you are familiar with. In terms of the distribution of students across our 3 research thrusts, you can see that our information and decision systems is the largest area, closely followed by our nano devices and nanosystems area, and our circuits and computer engineering area also has a very healthy number of PhD students. In total, we have about 140 PhD students in our program at any one time. Our admissions, our applications are open until the 16th of December. Some tips for applying. Select the research area you're most interested in, and make sure to that you have the opportunity to select 1 or 2 faculty advisors that you'd most like to work with. I would encourage you review their web pages and indicate that in both the fields where you can select faculty members. If you're interested in more than 2, make sure in your research statement to highlight the different faculty that you're interested in working with and why you're interested in working with them. Want to also mention that we have lots of members of our graduate group who are not primarily ESE faculty, so you'll see them on our website. So you can certainly be a student in the lab of anyone who's within our graduate group. And some of those faculty sit in our CIS department, computer information system. Many of them sit in our biomedical engineering or in MEME, mechanical engineering department. Some of them are in the medical school. Some of them have joint appointments in Wharton. So any of those faculty, as long as they're in our graduate group, can advise ESE PhD students. And the last thing is I would say that letters of recommendation are really important in the application process. So please, when you're asking for letter writers, make sure those letter writers really know you, that they can say some things that are very important about your prior research, for example, maybe somebody that you worked with in an internship, a professor that you've had for many classes. You can say something about the underlying knowledge that you've obtained. The more specific the letter can be, the more powerful it is in the admissions process. Our acceptance rate is 11%. I would also advise that the best way to get admitted to our ESE PhD program is to connect directly with faculty. All students are directly admitted into a faculty's laboratory. And you can kind of see that in our offer acceptance rate, because our faculty are very heavily involved in the admissions process. They're going to establish usually a relationship with you during the recruiting process. And usually that leads to our acceptance rate being fairly high, because you will have personally interacted with the faculty mentor you'll be working with, probably fairly significantly, even before receiving an offer. And with that, I think I would like to turn it over to Nicole, who will lead up the ESE student panel discussion.
Hi, Troy, thank you. I'm going to end the share. Thank you very much. I'm very excited to see everyone here today. Thank you again for our esteemed panel of current PhD students who are going to share some of their wisdom, really specifically on the admissions process, and offer some advice for how you can navigate that. Let us start by introducing yourself, and please tell us a little bit about your background and your research area. I'm going to start at the top with Behrad. Could you please begin?
Yes, sure. Hello, everyone. My name is Behrad Moniri. I'm a 4th year PhD student in the ESE department here at Penn. I work with Hamed Hassani on deep learning theory and information theory.
Claire?
Hi, my name is Claire Kendall. I am a fourth-year PhD student in electrical and systems engineering. I'm co-advised by Firuz Aflatooni and Insip Lee, and I work on electronic and photonic integrated circuit design for biomedical applications.
Sophia?
Hi, I'm Sophia. I work with Mark Miskin on broadly like nanotechnology, on microrobotics, as well as analog neural networks.
Seema?
Hi, I'm Seema. I'm a third-year PhD student, and I work with Hamed Hassani and George Papas on trustworthy AI. Yes.
Thank you. Mohammed?
Hello everyone, I'm Mohammed Agmadadi and I'm a second year PhD student at ESE. I'm working with Firuz Aflatooni and my research area is working on quick or quantum-inspired classical computing.
Thank you, Mohammed. Zakun?
Hi, I'm already a third-year PhD student in Professor Mark Allen's lab, and my research area focuses on magnetic design for miniaturized magnetic energy harvester, and also for the magnetic sensor for high temperature operation, which we jointly worked with Dr. Olsen's group for the past year. Thank you.
Thank you. All right, so I think we'd like to get a little bit into the nitty-gritty of the application process, and if you could discuss your application strategies. For example, did you speak with former faculty mentors at your previous university with any recommendations of other faculty to work with? Did they review your research statements? Did you utilize any resources at your school, such as the Writing Center? If you could sort of help break that whole process down for the people on the call, I think they would really benefit from it, because navigating the application process for the doctorate can sometimes be overwhelming. If we could go back in the same order as before, that would be great.
Yeah, sure. So I think the hardest part in the application process is finding the correct faculty advisors. I think that's the hardest part even before contacting anyone. And for that, I think like there are generally different ways. You can ask your former mentors in your, like, for example, undergraduate institution. I think they can help a lot. They have connections, probably, like they know people. And also like by looking up their papers, their research outputs, see what's happening in the area that you're interested in, and figuring out like who's working in the area. So I think these are like the typical ways that you can use to find the faculty advisor. And after that, it's just contacting them, and have to like somehow be sure that you have read their work, you know exactly what you're working on. You can be specific, write a short email, say, oh, hey, I know your research, you work on this and that. I know it, I've read it, I'm very interested in this, and I want to join your group, and send your CV alongside it. A very, very brief email like this, I think this is the way to contact. And after that, it's like recommendation letters, as Troy said, is very important. I think it's very important. But one thing that I realized much later is that although like all schools or most schools require 3 recommendation letters, like you don't really have to work with 3 different people on research projects, maybe like 2 research projects, one more on like you are their TA or some coursework. I think that's enough. So I was very stressed out because I wanted to have like 3 people who I've worked with very, very closely, and they can comment on my research skills. But that's not going to happen probably in undergrad. So I think that's one more comment that I can add. And after that, yeah, so I wrote my SOP, statement of purpose, myself. Didn't use any service or anything. But I think right now there is ChatGPT, so you can probably prompt ChatGPT to help you a bit, but maybe like not for the whole thing, maybe at the like sentence level. Yeah. So that's basically it. Yeah.
Thank you. Thank you for your insights. on the process. Claire, how did you navigate the doctoral admissions process, and what advice would you have to offer?
Yeah, so I agree with everything that was just said. It's really important to have a good relationship with your advisor and be really interested in the research that you're going to be doing. So reaching out to that person is really important. Looking at the different essays, the research and personal statement that you have to write. I had help from a faculty mentor at my undergrad university talking about the PhD application as a whole and even reaching out to potential advisors and what that would look like. And then he also helped me with the personal statement and research statement. And I had a couple different people read through that. So just leaving enough time to make sure that you can do some revisions on that and really think about your interests and who you want to work with when you're doing your PhD is important.
You bring up a good point in terms of making sure you leave yourself enough time. How much time would you recommend for that whole process? Meeting with your mentor, writing your research statement, and then receiving feedback?
Yeah, I can't completely remember because it was like 4 years ago how long I left, but for sure a couple months from like start to finish. So if you haven't started yet, I would get started right away.
Sophia?
Yeah, so everything that's been said so far, I would also agree with. I think a big thing for me when I was applying is I didn't know exactly what I wanted to research. I was actually a physics major and I wanted to get into engineering, but I had done engineering research in a field and I wasn't sure if I wanted to continue in that route or explore something new. So what I did is I kind of split it up into like two factions that I was applying for. One was like things that were very aligned with what I had already done, because I think that gives you like a good foot in the door. And then also just kind of things that I would go on engineering websites and just find like groups that looked like that just piqued my interest for one reason or another and tried to find things that matched up with like skills that I had developed. And so that's actually how I got here is I found my advisor's lab on the internet, and I thought that microrobotics just sounded really cool, and I had a little bit of fabrication experience. So I was like, what the heck? Yeah, so yeah, I agree. It's really about sending emails directly to faculty that you are interested in working with. Yeah.
Thank you, Sophia. Seema?
Yeah, so the process was really overwhelming. I remember when I was in undergrad, so I kind of systematically broke it down for myself. So the top level was, first of all, it was important for me of where I go to school. So kind of looking at the areas I'll be living in, what going to university there would look like is also very important for mental health throughout PhD. So once I was able to narrow down to the universities, then I went to their ESE departments. I looked at the list of faculties, and then I went and read a few abstracts from their Google Scholar profile, and then see what they're kind of doing, looked up what the buzzwords mean, and seeing which ones really align with what I've done in the past and which ones are really interesting to me and the things that I want to do. And then when I applied to each university, I kind of had 1 to 2 faculty in mind, and I made my essay very specific to them. So the first 2-3 paragraphs usually stays the same, and then the paragraph where you explain the research you want to do, you want to show that you're interested in what they're doing, but you know what you're talking about. So this doesn't mean that you have to pretend you've done what they've done, but be honest about what you've done and show that you know what some of the buzzwords mean. And this way, maybe you have and usually like they recommend listing the faculty in your application or in your essay as well. And this could help get the essay to the faculty, but this wasn't always the case. Sometimes I had to stay more general and didn't really list any faculty members, but because, I was very specific about what I had done, then the essay went to the right faculty. So I think you want your essay to be in a way that catches eyes for the right person. So keep that in mind when you're writing it. Yeah.
Thank you, Seema. You describe a very thorough process. And particularly you mentioning the faculty in your research statement and demonstrating how your work, what you've done aligns with them. Thank you. Mohammed, would you like to share your process?
Yes. Kind of like all other people told the necessary and essential notes, but I just want to add that all of our faculties in ESE have the specific research website that you can go through them, see the research area that they are working, the team, the funding agencies they are working with, the recent publication they had, how to contact us. Some of them has, if you want to be a PhD or graduate student, you can directly email. They have some description how you can email the professor. And I think after reading several, because based on your undergrad, you have some feelings, what are the projects that you're gonna work. You can change it from the fully nano device to kind of like AI. It's possible, but kind of like you have some sense what are the projects that you like to work on. You go through the research websites and find the professor that you think you have aligned research perspective, and then send just a straightforward email. I'm, for example, Mohammed Al Maladi. I did my bachelor here. I read this paper. I'm really interested. Just send the email with your attached CV. That can be done. That's the whole work.
Thank you, Mohammed, for sharing that. And did you use any services at your undergraduate institution in terms of helping writing with the writing center, or did you share your research statement with your then faculty advisor?
I think for my research kind of like a statement, I talked to my mentor and I had some review with him, but not any kind of like writing something.
Okay. Thank you very much. And I think Sakun maybe can offer a slightly different perspective because he is a Penn alumni. Correct?
Yes, yes. Actually, I work in a mechanical engineering lab during my master degree. So at that time, for the research statement, I asked one of the senior PhD students in my former lab for reviewing my research statement, and he was very nice. He gave me a lot of valuable advice, ranging from structure, logics, grammars, and so on. Since he is a native English speaker. And going back to the strategy, I think it is really important to make a list of your application to collect and compile all the information you needed, including school name, potential groups, research areas of these groups. And I remember that I listed the targeted research group into two parts. One part was the research area that aligned well with my previous research experience during my undergrad and master degree. And the other was the area that I felt really cool and I became interested in. And don't be too panicked about applying for a group that might not be so relevant with your past experience, since I think PhD admission is more about how suitable you are, not just how competitive you are. So based on this strategy, I just searched the most published work in the group I'm interested in and compiled all these informations and also make a list of preference in sequence. And then I just finish all my applications. Yeah.
Thank you. Thank you very much for offering that perspective with everyone. And we have a few more minutes before the call goes back to a general Q&A. So if everyone would just like to share how they prepared for their interview, I know that's something that can cause one to be nervous. So your interview with your prospective faculty advisor.
Yeah, to be honest, I don't remember how I prepared for it, but the only thing I remember was that it was stressful. So
Okay.
but probably my advice right now would be to just have a look at what they have been doing recently. Like maybe not read all their papers, but know what they are doing, what they are interested in, like the general theme of the papers they are writing, what, for example, tools are they using, what techniques are they using. So maybe like it can help you in the interview process. I think that's the best thing you can do before the interview.
That's good. So don't get be familiar, but don't overwhelm yourself
Don't
with
overwhelm
information.
yourself. Yeah. It's impossible to read like all the papers. Just know what they are doing in general.
Okay, cool. Thank you. Claire?
Yeah, just to add on to that, I think just be prepared to talk about yourself and like a little bit about your experience and your interests. And then I would prepare questions. It's really important to have a good working relationship with your advisor. So just think of questions about their advising style, their research, the lab environment, things like that. I think that'll really help to show your interest and get to know that person better.
Good. That's a good point. You want to have questions for them as well, and get to know their style. Thank you. Sophia?
Yeah, I would definitely emphasize like being prepared to talk about like what you're interested in. I think that is always something that's important. I think one question that I asked that I think may have like helped is like when you're looking for faculty, I asked like what about like Penn is beneficial for like this area of research, and kind of got their take on like, you know, why should I want to come here? Because I think that's also important to ask, and it'll show in your like essays the more you know about like the place you're applying, I think. And yeah, just like relax. I mean, no one's application is perfect. Like I was so stressed out, and like, you know, it's like it'll all be okay.
That's a good point. No one is ever perfect. Thank you. Seema?
Yeah, I think when I was preparing, first of all, like you don't need to pretend that you know everything. You know, you're coming to do a PhD. They don't expect you to already have a PhD. So you don't need to speak to them as if you already know their research and all the details. The faculty are very quick to pick up on this. I think what's very important is to kind of show them you have a half good idea what to expect from the PhD process in general, show that you're enthusiastic, you know, it's going to be difficult. You've spoken to people, you've done your research, you've heard about the ups and downs, and this is something that you want to do, and you're excited for it, and try to ask them the right questions for you too. Like, see, what do they think your process is going to look like? How important do they think the courses are versus the research? Try to see what their opinions are about the whole PhD process. And then that kind of gives them a good impression that, you know, you're not doing this blindfolded. You kind of want to go into it and you have high expectations and you want to deliver. So ask questions, and yeah. But it was stressful and it doesn't always go well. Just even if it doesn't go well or if you stutter, just stay there strong till the end. It's okay.
Gotta keep moving. Thank you, Seema. Mohammed, what advice would you have to impart on the interview process?
I think I exactly remember my interview with my professor. It was at first it was really stressful. It should be. It's kind of like you are applying for a PhD, you are interviewing with your professor, so it has a little bit of stress. But the thing that I did, and I think it's really helped me through the process, I made 6 slides of PowerPoint about my research past research, the faculty that I work, some of the undergrad courses that I did. I think it's really aligned with the this lab that helped me to be sooner involved in the projects, and it's kind of like break the ice at the start of the interview. And after that, my professor started to ask me some questions about kind of like, what do you like more? These are our projects. Which one do you think you are more aligned? And kind of like this, kind of a normal conversation between two people to do you align to each other to work with each other for 5 to 6 years?
Yes.
That's the whole point.
That's a very good point. And thank you for offering that advice on coming to the meeting with a few slides of your research. Thank you. And we have a few more minutes before we send it over. Zakun, would you like to share your strategies for the interview process?
Yeah, I will just quickly talk about it. So since I was previously a Penn alumni, so I will try to make an in-person appointment to talk with my preferred faculty. And I also remember that I prepared a few slides for introducing my previous experience and then arranged them into a logical story to make my preferred faculty to understand what I'm doing now. And I also let him know what I'm interested in his field to say like how my experience will help to contribute to the group efficiency and how to contribute to the innovation of the research project and so on. Yeah.
Good. Thank you everyone for your wonderful contributions. And I know we went a few minutes over, and so we turn the conversation back over to admissions, I believe, now for the wrap up.
Yes. Yeah, so really anything, any other questions that anyone may have, feel free to put them in today's program. We do have one question I'm hoping the programs can answer. Essentially, the student is asking that one of the faculty members that they're interested in working with, they want their application viewed by, but they're not on the list of the pull downs. How can they ensure that their application will be viewed?
I think the best strategy there would be to make sure you indicate in your personal or research statement that that's a faculty that you're interested in working with.
I also, Jacqueline, maybe we are past a certain point. I know earlier on, Christine was able to add a faculty for me. The reason that happens, I think, is because sometimes there are faculty that are coming in that haven't technically started yet as teaching faculty, full tenure, whatever their appointment is, but the word has kind of gotten around and the interest is there. I don't want to assume that we still can add people late. That might have been, an exception that was made early on in September before applications were to the number they are. So if that's the case, we still will make sure that your application is viewed by that particular faculty member. It's just that they may not have started yet, so they're not in the system.
Yeah, that's something we can reach out about, but I definitely recommend adding it to another spot in your application because you don't know how quick that turnaround can be up until December 16th. So. Anyone else have questions, please put them in the Q&A box. We do have are applicants from Nigeria eligible for the English proficiency waiver? It all depends on what where you attended. Yeah.
Sorry, I asked to speak. Sorry for cutting you short, Jacqueline. Hope you don't mind.
No, go ahead.
Yes. Okay. Thank you. I mean, this is an interesting session. I mean, I'm currently going to be applying and throwing in my applications towards a PhD in mechanical engineering. However, I wanted to confirm, what's the impact of reaching out to research students within a lab? I was able to reach out to professor and I reached out to students, and it was very much intriguing, engaging with the students. Does it really make any impact? Like, what's the effect, and what are the prospects with regards, getting the professor to align with you and getting on a Zoom call with you? Is there more like a high prospect for that? I mean, also speaking with current students at the moment. Sorry, I'm Ethelbert from Nigeria. Yes.
All right, so maybe I can take that one. So I would say faculty receive a lot of emails from students. So if you want to reach out to a faculty, make sure you don't send templated emails, but send a more thoughtful email. Go read up the faculty's website. Same thing if you want to reach out to students as well. And a thoughtful email where you show that you have, read the faculty's publication, show genuine interest, I think will improve your chances. Spray and pray, send 100 templated emails to faculty is usually unlikely to be as effective.
Fantastic. Thank you. And I think with that, that should wrap up all of the questions. We appreciate everyone coming out today and our programs presenting. If you have any questions, again, feel free to contact admissions. And feel free to attend any other sessions that we have. Like I said, we're doing a series of 3 PhD open houses. So we have 2 more, one on the 18th and one on the 20th. And we do have an Ask Admissions event and a coffee chat coming up in December. So again, thank you for coming out today. We really appreciate it. And we look forward to reading your applications and hearing from you soon.